Alrighty, hello everyone. Welcome to our next workshop. I'm gonna kill just a couple of seconds on stream here since I know folks are coming from the last one, so you might get served an ad before it starts actually showing the stream. But thank you everyone for tuning in today. I know we just had a great workshop from the folks over at 11MQ, and I'm super excited for this next one we have from the GitHub sustainability team. So I'm going to actually hand it over to Asim, who is the executive director at the Green Software Foundation, who's going to be telling you all about the cool things you can do with GitHub sustainability and green software as a whole. So I will hand it over to you. You can take it away.
Hi, thank you. And yeah, I should mention well, I'll talk about in a second, but I'm the executive director of the Green Software Foundation, and GitHub's a member of the Green Software Foundation, so I'm not a member of the GitHub sustainability team. We work very closely, and kind of GitHub's been a founding member of the foundation since the beginning. But just want to make sure there's no assumption of affiliation. So let me start off. This is probably not I don't know the nature of the presentations you've been seeing so far. This is probably going to be a very different presentation than anything else you're seeing. You might be able to guess from the first slide. So what you're seeing there, that kind of club-looking thing on the left-hand side is a maquitl, and that is an ancient Aztec close quarter combat weapon, and it was basically a club, a piece of wood, and on the edges of it is obsidian. So obsidian is like a volcanic glass, and if you chip obsidian, it creates an edge that's or can create an edge that's sharper than a steel razor blade. So it's a kind of a gruesome weapon, but very effective. And so one of the things that people might not know about the Aztec Empire is that it's in one of its inflection points was when it became effectively a trading hub. So they were on an island, and on the island you couldn't grow anything. There wasn't enough, animals to hunt. So they said, we'll become a trading port. And so they told everybody around, they come over to our trading hub. Pop over. We guarantee your safety, and we guarantee you won't be cheated. Leave your maquitls at the port. Come over, bring your produce to sell, bring your money to buy produce, and they had warriors kind of wandering around and kind of keeping everything safe. And one of the things they were quite strong on was making sure no one was cheating. So if you were trading with a tradesperson and you thought they were cheating with a weight, they weren't using kind of what the area was using as an official weight, and they were trying to cheat you out of something, you could call the police over. You could say, I think this person's cheating, and then the police would have on them, police warriors, the police would have on them, their own standardized weights, and they would then compare. It's very easy to compare like two weights versus each other with a lever thing. And they would compare it with the tradesperson, and if they found the tradesperson was cheating, prisons. You pretty much there was one punishment for everything, which was death. So that maquitl comes down and then chops off the head. I don't know, but you're not surviving. And that's interesting from a start. But I think what I think is most interesting about this story is that if you call the police over and the tradesperson wasn't cheating, so if you call the police over, someone's now. I start off a lot of my talks with the story because I want to. It's a fun story. It's interesting, but also as a reminder of a couple of things. Sustainability is life and death. I talk and I meditate on death quite a lot. I think and I think it's a good reminder of that. So it speaks to kind of the nature of this talk, which is about measurement and how measurement is power, right? Measurement is life and death. You died if you measured incorrectly. This is talk about power. Who am I? My name is Asim Hussain. I'm the executive director of the Green Software Foundation, which I co-founded over 3 years ago now. And since launch, we've grown from 8 to kind of 68 members now. We're a collection of non-profits, academic institutions, enterprises, If you know Linux, we're part of the Linux family, Linux Foundation family of foundations. And our vision is a future where software has zero harmful environmental. We're a standards and policy foundation. We do a lot of open source as well, but like what drives a lot of that stuff is standards. We're a big believer is, how we believe we're going to make that vision come true is through by creating standards and then getting those standards adopted as policy and building tooling to make them easier to use, etc., etc. Our most advanced and mature standard is something called the Software Carbon Intensity Specification. You may or may not have heard about this. It's carbon per something. So this is on StreamYard, or YouTube. I don't know exactly where you're watching it, but like a streaming solution might be carbon per minute. And then obviously the standard kind of goes into a bit of detail as to what do we mean by carbon? What do we mean by minute? That's what standard is. Standard is let's set in stone, so there's less room for interpretation. Um, and Yeah, and the SCI was built from the ground up by engineers who've been trying to measure software's environmental impact for years and years and years and years. I recommend you go to our website and kind of you'll find it there and look at it. Oh yeah, we got it into ISO. I don't know if you know much about ISO, but it's an international standards organization. So we work through consensus. Everybody's got to agree on every single line. You think reviewing a pull request is hard? Try creating a standard and getting kind of a one sentence change to it. It requires a lot of review. And ISO, if you don't know, is a global review. So SCI got reviewed by 100 bodies in 175 countries, and it's now an ISO standard. So it's a big bar you've got to get to become an ISO standard. And now we're just seeing it just get adopted everywhere. Like organizations are setting it as KPIs. It's already being used in academia and a lot of reports, but there's really growing an adoption there right now. Where's the future? As you can guess, Sci for AI. There's a lot of like room for interpretation for a lot of these measurements. What do we mean by carbon? What do we mean by energy? What do you include? What do you not include? And kind of there's a lot of interest in creating really domain-specific versions of Sci for AI. Actually, I've got it here, but the next one's probably going to be Sci for Web, Sci for blockchain. And we talk about AI. Blockchain is still significantly a bigger consumer of electricity and emissions than AI. But AI is the latest darling. Obviously, Cypher Gaming and Cypher Finance. So that's kind of what's next. I always want to throw it in there. If you're interested in joining us, please come reach out. There's no reason, if you just want to engage in the work that we do, that's absolutely fine. Everything we do is open source. Everything we do is Creative Commons. You do not need to join to take advantage of anything that we do. But if you're part of an organization that kind of wants to be involved in some of these stories, wants to help start defining these standards, come and join us. Non-profits and academia. But if you're part of an enterprise, we're funded through our enterprise fees. So there. So what is this talk? Let me dive into the talk now. What is this talk? This talk is doing for sustainability what open source did for software. So I've been looking at this space. I've been very lucky to look at this space for quite a few years now. 6 years maybe I've been looking at this intersection of software and sustainability and just been asking this very, very, very focused question is how do we reduce the environmental impact of software? So after all these years, my answer is very refined. It's kind of hard for me to have conversations with people because I've been thinking about this one thing for such a long time. So my talk is an attempt to explain the answer as I see it, and actually really kind of how to make a real ding in this problem. I should also make sure I'm clear here. The foundation works through consensus, which means everybody agrees on things. I try and make it clear through this talk when I'm talking about something which is a consensus position, whether I'm just talking about something which is a conversation that we've had, or whether I'm just talking about Asim's dream, what's in my head. So I'll try and make clear which of the three. It's very important what's consensus and what's not. So I'm going to talk about power, not electricity, but power. This is my rubric, probably not what you're expecting. I'm going to talk about measurement. I'm going to talk about a tool, an open source framework that we've been building for a while called Impact Framework. And if there's time at the end, I'll be here for Q&A, and just kind of answer any questions that you've got. This works better if I'm live on stage. Let's see if it works. Actually, it doesn't work. So I've got to ask you a question, and I'm going to wait for a response. Oh, what the hell? Oh, it's in my notes. I'll give it. Did you know what this is? Probably going to guess. Yeah, I don't know. I can't hear you, so I don't know what you're going to say. You're probably going to guess that it's a hand. Maybe you're right. But actually, it's a cubit. I don't know if you can actually even see the whole of it. Hopefully, you can. So a cubit is a distance from my fingertip, my elbow. And there's kind of ancient Egyptian. That's one of the cubits from Egyptian unit of measure. So one of those things. So pretty useful. I don't think the Egyptians invented this. I'm pretty sure it's a dawn of time. We were probably like measuring things with our arms, but cubit is from that term. And the Ethiopian in Ethiopia, there's still a proverb which is send your friend with long arms to the market, which I think is pretty cool. Kind of a measurement nerd these days. Because I just think it's such a powerful tool, and I want to try and get that across to you. So the talk can be littered with a few of these little things. So now we're going to talk about power and the asymmetry of power. So what is power? So I define power as what is the good definition I like. Power is the ability to influence people and events. Major League hacking invited me to speak at this event, so they had the power to influence that. So power is the ability to influence people and events. But power isn't good or bad. Okay, this is me, by the way. This is not a GSF consensus position. This is Asim's rubric of the world. So power isn't good or bad. It's good. What you do with power can be good for some people and bad for other people. It's also not a state. However powerful you are, there's always somebody more powerful, and however powerless you are, there's always somebody always less power with less power. So it's just a spectrum. It goes to minus infinity to, I don't know, plus infinity. For me, it's more about the vectors of force. So there's forces at play that work to concentrate power into as fewer hands as possible, and there's forces at play that work to dilute power into as many hands as possible. That's how I think of the world. And when I think of sustainability at its core, when I think of it's a fight against the concentration of power. It's a fight for the dilution of power. That's truly what sustainability is. 70 companies, 70 companies in the world are linked to 100% of global emissions. 70 companies. I'm on the side of the force that works to dilute power. Yeah. And so what are some examples? How do I look at all technology? I look at everything through this rubric. We have a bunch of different rubrics, but this is one of the ones I really enjoy to look at everything through it. So I look at kind of different technologies through this rubric. I look at democracy is a technology, right? It's an invention. So democracy is a dilution of power. Somebody woke up one day and invented voting. Democracy is dilution of power. The internet is a dilution, as a technology that dilutes power. It took knowledge. All the knowledge in the world is now available to me on this device, right? Or this device. So the internet has brought that power to me. It's diluted that power and made it available to many more people. Blockchain gets a lot of criticism in the sustainability space, but ultimately, blockchain is an attempt at the dilution of power. So when I think of open source, the way I think of open source is as a dilution of power, away from the closed source ecosystem that existed before it. If you're kind of new to the space and you were, I wasn't that old during the transition, but there's a big closed source ecosystem prior to this. Several times in my career, I've had executives, who've been a little upset about an open source project that scuppered some plans, and have a conversation with me, and what can we do about this open source project? What can we do? And I remember I could see the moment on their face when they realize they don't have the power, because you can just fork something and move on. I mean, open source is a beautiful dilution of power. And so the way I think of like the sustainability space right now as like a kind of closed sourced ecosystem, it's very private. Getting access to data is stunningly hard. So power is not in the hands of many people. And so I think about like what do we need to do in order to dilute the power in the sustainability space the way open source diluted it in the software space. And I believe it's measurement, which I know is a hard sell for a lot of people, but hopefully I'm going to try and sell it to you today. Right. Again, this works a lot better when I'm in a live audience, but we'll give it a go now. So what's this? Woof, woof. Um, that is actually called a penning kulmer, which is an old Finnish unit of and it was a distance you could hear a dog bark, and it might sound a bit dumb, really, because you're like, well, hang on, like if you're in a wide open space, you'd hear a dog bark for longer. If you're in a thick wooded forest, you'd hear it bark. The distance would be less. But that was kind of the point. They told you information about the terrain that you're running along. You're walking along it. We've lost all of this stuff in this kind of world that we're in right now. We're told different stories, but it was a valid, useful unit of measurement which was available to everybody. Everybody used it. A lot of us use it today. I flew over. Currently at a conference in Vegas, and I flew over. And, it was about a 4 podcast journey. So what's a podcast? I don't know. You don't know what podcast I'm talking about, but that's what I'm talking about. Units of measurement. Anyway, going off on one. I love this slide, which is units of measurement are for the powerful slide tools of subjugation. Each time they're deployed, they turn the world into a place that continues to make sense as long as the power that legitimizes the measurements rests in place. So, measurement has been used for thousands of years, tool for manipulating power, for both concentrating and diluting power. Let's look at a few examples. So, does anybody know how the metric system came about? I'm currently in America. I think it's hilarious that the metric system is used here. But anyway, how does the metric system come about? If you don't know, it's actually the French Revolution. So lots of people are really fed up with King Louis XVI and the corruption of his empire. So he asked people to create, and I'm not going to pronounce French is terrible. I'm not going to pronounce it properly, but the Cahiers de Doléances, which is kind of a book. And he said, "Listen, why don't you go away and just write out everything you're pissed off at me about, and then hopefully that'll." He was hoping to just help them let off steam. The peasantry wrote in the book, "Listen, the nobility and the clergy are just screwing us out of money. I grow all this wheat and I go to my baron to kind of sell it, and he claims it's a lot less. So they're all getting screwed. Same way the Aztecs, with the weights. Everybody's screwing everybody else over on with the weights." And it didn't make things better. In fact, it kind of made things worse for the King Louis XVI. The middle picture, is a famous one, the martyrdom. Like he basically got executed. A lot of people are dying in this talk here. A lot of death here. But what that led to is that afterwards, they developed a system of measurement, which is described as for the people and by the people, and it's called the metric system. So, and to ensure it was a measure that couldn't be cheated, it was going to be linked to some unalterable value of the earth itself. So rather than like a foot being, the king's foot, I don't know if it was that, but there are things like that, some unalterable value of the earth itself. So a meter was going to be a percentage of the circumference of the earth. It actually triggered this huge, beautiful enterprise to actually figure out the circumference of the earth. Once you know the circumference of the earth, the meter will never change. And a kilo was a 10 centimeter by 10 centimeter by 10 centimeter cubed volume of water. And so if you knew the meter, you knew a kilo, and both of them couldn't be changed and cheated, and that was the intention. And anybody could then kind of like figure it out. Well, you could pass the meter on to other people. Now we know actually that the Earth is not a perfect sphere and things weigh differently at different places, but that's what the intention at the time. So what's the conclusion to this? Measurement was used as a slide tool of subjugation, but at the same time was flipped into a tool for the people and by the people, right? I love the story. Does anybody on this call know where the term carbon footprint came from? So if you don't know, you might be quite upset over the next slide, but actually, the term was first popularized by BP, British Petroleum, in 2004. They were getting challenged because, global warming and wanted to have a response. So they hired the PR firm Ogilvy and Mather to find a solution. So what they created was the carbon footprint calculator, not to measure BP's footprint, but to measure your footprint. 70 companies in this world are linked to 100% of all global emissions. But it's a shame we have this global warming problem because of your personal carbon footprint. It's not your footprint, it's their footprint. Okay. I personally don't subscribe at all to that. Even I don't have a personal carbon footprint. I don't subscribe to that at all. And I love this move, even though I kind of I think it's genius. I truly I meditate. I sit and meditate on this move. It's one of the best chess moves I've ever seen played in this space, and genius. It flipped the script with a single ad campaign. I know plenty of people in the startup ecosystem of very big firms that are now doing personal carbon footprint calculators, despite the fact it was driven by fossil fuel campaign. BP, by the way, I should give them a little bit of credit. That the latest CEO has changed their stance completely, and has agreed never to kind of do any lobbying and anything in this space again. So hats off to them, and let's hope that carries on. I don't normally talk about this slide because it actually takes me a little time to walk through it. So hopefully I will have the time to walk through it this time. And I think it's important, but this is going to be a hard one to explain. So when a company reduces its emissions, what does it mean? What does it mean when you say reducing emissions? So, oh my God, I'm going to try and explain this. So the main standard that organizations use to compute kind of corporate emissions is something called the GHG, Greenhouse Gas Protocol. And Scope 2 is the emissions from the electricity that you're consuming as an organization. So pre 2016, the way the standard was written, as an organization, you had to compute, disclose how much carbon was emitted from your consumption of electricity, right? You could be a responsible organization and say, do you know, we also bought energy offsets. When organizations are like 100% renewable, they haven't put a wind farm on their site. They've just bought financial contracts called renewable energy, because those are called energy offsets. So you can be a responsible company and just say, look, we emitted this much carbon, but you know what? We were responsible. We bought offsets. We did what we could. After 2016, a few lines code change the specification, changed the nature of what you could report. You could then report net. You could then compute your actual carbon emissions, take away your offsets, just tell the world that you only emitted this much carbon. I'm trying to be very clear here. I'm not saying you're telling the world that you emitted this much carbon, but you bought offsets. You can just say, you can forget the left-hand slide and just say, we only emitted this much carbon. You can do that. That's called market-based reporting. And this left one is called location-based reporting. And so this was appealing to a lot of organizations, since it allowed them to show a quick win in sustainability. They didn't do anything. They didn't actually make their software more energy efficient. They just went from location-based to market-based reporting, and then, we reduced our carbon emissions by 100%. And interestingly, I call this the renewables loophole. And interestingly, this doesn't include nuclear, so I think is fascinating about this. Nuclear is zero carbon, right? But it's not renewable. And the only energy offsets you could do this thinking is a renewable offset. So it's a loophole that only benefits renewable companies. It's also is not ubiquitous across the whole of GHG. You can't plant a tree and then say I made this much carbon, I planted a tree, and my actual carbon emissions. That's no, you've got to do kind of effective location based with kind of tree planting. This is this loophole that only benefits renewable energy companies. You've got to ask, how active was the renewable energy lobby in kind of adjusting this thing? And in a way, it's this one line code change. Think about how much money this slight change in how something was measured but maybe $1 trillion into the renewable energy markets. Measurement is power, right? And it kind of like it has now created for us like a really weird situation. Pre 2016, the post 2016, there's now no difference. This is what so frustrates me about this decision. There's now no difference between two companies. One company, let's say the tech companies, one company is a responsible one. They have optimized their software to the max. They really put extra effort into making sure it's incredibly energy efficient. That's the right-hand side, right? And that's how they reduce their carbon emissions. They did that. There's now no difference between that company and another company that goes, screw it. We won't do any efficiency measures. We'll just buy energy offsets. Both of them can now report the same carbon emissions, right? That's wild to me. So in a way, like what that did, like what we want is the world on the right-hand side. As a tech person, this is what I want. I want trillions of dollars to flow into companies to actually make software more energy efficient. Unfortunately, because of this change in how this measurement standard was this change this measurement standard, that money's flown into renewable companies, right? Measurement is a chessboard upon which the game of power is being played. And if you don't know that, you're the one being played. Right. Now, so if measurement is the chessboard, our best move to dilute power, as I see it, is open and transparent carbon reporting, which anyone can do for anyone else. This is really what impact framework is all about. It's kind of a lot of things, but this is actually I didn't even come up with this tagline. Somebody else was discussing it on a podcast, and they said, "I think it's a solution to opaque carbon reporting." We were like, "That's a great tagline. That's exactly what it is. There's a solution to opaque carbon reporting. We want to make this transparent. You know what the hell's going on. What is it? There's nothing out that's quite like impact framework, so we often struggle to define it. It's a bunch of different things. A custom calculator for environmental impact, and it kind of helps you. It helps you to merge kind of like a dozen other methodologies, so you can do like an end-to-end calculation for a software product. There's a lot of different things that help you compute like a different slice of a pie of a piece of software. But to do an end-to-end thing, you need to pull it all together. It helps you pull it all together. But also, it's a file form for communicating environmental impacts, which is what I'm even more excited about. So that's where things are getting really interesting in this space. But it basically helps you compute environmental impacts. I'm going to show you some parts of it. It's very, very big. I'm never going to go through it. I've given up trying to even give a presentation on it in an hour, which is I talk about death and murder. But I'm going to give you a quick overview of it, and then there's lots of places you can go to find out more information. But in order to, if you understand some of the core concepts, in order to understand what I'm about to show you soon, you have to understand some core concepts. And that is of observations and impacts. Impacts are like the environmental impacts you want to measure, like carbon, water, the size score, all sorts of different things. That's the stuff on the kind of the right-hand side of this animation right now. Most organizations don't tell you the impacts of the software that you're running on there, or the services that you're using from them. They probably don't even know it themselves. Even if they know it themselves, they don't know how to attribute your portion of it down to you. Even if they do, and there's very few organizations that do this, but even if they do, the methodology they use might be private, so you don't know exactly how they computed it. It might not be granular enough. It's very hard for you to actually figure out what your impact of your software product is. So what the kind of the community of people started to do was, you know what, we're going to figure out all our numbers by ourselves from data we can get access to. So they would take things like CPU utilization, number of installs, network transfer, size of a page, all sorts of things, and they started building models to turn that environmental impacts. And we call that the data that you can get access to, we call it an observation, because you can observe it, right? You've got it, it's in your hands. So what Impact Framework does, it takes observations and turns them into impacts. Now, how it does that is through what we call like models and model plugins. So a model is just a small piece of code, and it can be tiny, it can be a couple of lines long. It takes an observation and enriches it, adjusts it, transforms it somehow into an impact. Like for instance, we've got a model plugin. There's quite a few of them now, but there's one particular one I'm thinking of, which takes CPU utilization and turns it into energy. So that's a model, right? That's we call it induction, taking an observation to impact. That's a model that induces that impact. There's loads of them now. We're not the first people to even like think about doing this, but what the impact framework community ended up doing is, at the start, like a year or so ago, they started to build these really big monolithic models. Like, this is the model for Amazon Web Services. But then they realized actually that doesn't make any sense. There's actually lots and lots and lots of smaller models like we want to cherry pick together to give me the computation that I need for my application, because my application is unique. Every application is unique. Anybody telling you they've got a one-click solution to measure and to see it is very, very unlikely. The solution here is, this is those hard problems to solve, and everything is going to be fairly bespoke. Just as every piece of software is just a bespoke thing. I mean, you're all developers, like writing bespoke bits of code. The none of it, of course, is going to be bespoke. So you can customize a pipeline to get exactly the computation that you want for the thing you want to compute. Okay, I think you've got enough for the rest to make sense. But now I'm going to start showing you things outside of the slides. So drum roll. This is how we're going to change the world. Yeah, that's right. I'm showing you a YAML file. I know this is hard to believe because I was started this whole talk with these lofty statements about power, and I talked about a lot of people dying. And now I'm showing you a YAML file. Yes, we're going to change the world through a YAML file. This is what we call an impact manifest file. We actually call it an imp file, .imp file. So what this is what this file particular. This is how you compute environmental impact using Impact Framework. This current one is a size score for the Green Software Foundation website. So it's got everything in here. It's got all of the plugins and models that we're using, all of the coefficients, everything is baked into this one file. This is fully transparent measurement and reporting of measurement. So this is everything. So you can see it's all of it here. I'm going to scroll down to something, and don't trust me. I know I'm going to start losing people soon. This is only a short amount of YAML I'm going to show you. Then I'll show you something else. So for instance, this is an entry. No, I'll go down far. Here we go. So this is kind of part of what we're computing. This is what we call a component. A component is something that emits emissions. This is the component that we've got for our website, which is the emissions from storing our code in GitHub. So this is the emission that Joseph, who's a climate scientist, has been climate scientist for 12 years. He's now the product owner of Impact Framework, and kind of he built this model here. So this is all the little model plugins that we've now joined together to compute the emissions of storing our code on GitHub. And what this is an observation. I told you this is what an observation was. This is the things we can observe. So what can I observe? I can observe the number of site visits and some other bits of information to our website, right? And then at the bottom is the outputs, and the outputs is where we start seeing like impacts like energy, carbon, and so on. So what I'm about to show you next is still it's not public yet, but it's one of the best ways we have of displaying it, because I know it's very, very hard for people to read one of these YAML files. Even for me, a non-trivial YAML file is very hard to read. So we started to build a visualizer. This isn't like a tool. This isn't a dashboard that's computing stuff in real time. This is just reading that file and displaying it in a tool. There's no there's no reading of additional data. There's no dashboard. There's no real time. It's just this file presented with widgets. So you can see at the top. You can see this file. You can configure impact frameworks. It's very, very low level. It's very configurable. You can compute SCI, you can compute GHG, you can compute carbon, you can compute water, you can compute whatever you want. People are doing it for all sorts of things. It's a way of communicating what you've computed. So you can see here we've computed carbon and a site score for the month of August. Carbon for our website is 2.4 kilos in total, but the site score is 0.13 grams of carbon per visit. But I mean, oftentimes this is where people end. You get to hear a big number from a product or a person or a company. This is our emissions. But really, what we know after years and years and years of looking at this space and kind of diving into it, that's all well and good. But if you want to know what you need, what actions you should be taking, where you need to put investment in, what you should be working on next year, what you should be looking at, you need detail. You need granular detail. You need kind of temporal detail. So this is kind of we computed this with a daily amount, but you can actually do seconds or microseconds. Doesn't really matter. Time is just a choice of yours. This is a daily choice. So you can see the carbon kind of varies quite a lot day by day. The SCI is a little bit more stable, as you might expect. So let's kind of dive into what we call a component breakdown. I showed you a little bit in that YAML file. Like, it's not just about the total over time. Like, what the hell did you include? Like, when you say your website, what are you talking about? What have you computed? This is where we see there's so much fuzziness every time someone reports a number, because you think it's an apples to apples comparison, and it's not, because software is amorphous. What one person thinks a website is a different from another person. The front end engineer thinks the website is just the browser. The back end thinks it's just the back end. Like, what are you including? So that's why it's really important in an aside computation, in all computations, to kind of discuss like what is it you're computing. So this is you can store it in a tree, any kind of tree structure that you want. And what these kind of leaf nodes are is what we call components. A component is anything that emits emissions. It's called a component. So the storage of our source code emits emissions. We're running this on Netlify. If you know what Netlify is? It's a build platform for websites. We're using a CDN. There's networking. You got to actually transfer this stuff to the end user. There's a user viewing it from a browser. Like, what's the emissions from that? So that's kind of what we see. And you can see even from just this high level breakdown here, you can see actually most of it is from users browsing our website. The servers part of it, storing code in GitHub is minuscule. Network's kind of fairly low as well, which is a surprise. So that's kind of like where you see the breakdown. This is what I showed you in the YAML file earlier on, and if you can actually dig into one of those cells, you can see kind of what's working on. This is the inputs. These are the observations. This is the pipeline of plugins. Each of these is just a little bit of code that you can pass through. All of this gets passed to this. All the output that gets passed to that, gets passed to that, until eventually this is the outputs. This UI is not great. It's not right yet. It should really be showing you kind of what data is linked through a pipeline to the rest, but we'll get to that later on. I just want to show you kind of that's how it works. Observations induced into impacts through a pipeline of plugins. Yeah, let's take a look. I mentioned before, like where's all the emissions coming from? Total. Let's look at the total emissions. Like it's just jumping up and down. Uh, Everybody's obsessed with totals. We've been talking for a while. Totals is a pretty poor KPI to give to a software team. Look at these totals; it's just going up and down. Why are they going up and down? Because I'm getting a lot of visitors to my website. I want a lot of visitors to my website. More visitors come to my website, more people know how to green their software. Why would I want less visitors on my website? I want more. So like a total is if I was making decisions based off of like this total going up and down, it's not useful to me as a decision making tool. It's what we call a lagging indicator. Like total is a lag. Total tells you what did happen. The SCI is kind of more of like forward. It's like a leading indicator. What will happen? If you're trying to like figure out what to do in this world or where to go by just looking at totals, it's like trying to land a ship in port by only looking backwards. It just doesn't make any sense. You need size. So time makes a lot more sense as a KPI. For the software team, it's more stable. Like really, your size should be going down over time. That's really what you should be accomplishing if you're being green. So you can see it's a lot more stable. But I can see here there's a bit of a bump. It's quite a significant bump actually, 0.17. 0.12, like what the hell drove that massive bump? Let's dive into it. We can see that's time slot 15. I can look at 15. Let's close that. So it's not that. That's 000. It looks like server had a bit of an increase. Networking's the same and users the same. So let's dive into server. What was it? So you can see, look at 15. It looks like, yep, it looks like the Netlify bills. So you can see the day before it's nothing. The day after it's quite a lot more. The day before, I know what's going on here, by the way, but the day before the builds is we had one build. We have a static website built, so we had one build, and on this day we just did a lot more builds for whatever reason. We did a lot more builds of our website, and that created emissions. So on that one day, the size score it just nudged the size score up a little bit. Do anything with this information? But the other things that might surface to me where I'm like, oh wow, I didn't realize I'm spinning up servers when I didn't need to on that particular moment in time, particular day. That's kind of why it's more of a useful metric from that perspective. Like what we will have in the future is like there's going to be like on our GitHub repo there'll be a badge. You click, those have our size score. You'll click that, and I'll point you to a visualizer, and then you can kind of like see why evidence we make when I'm telling you my size score is 0.129 grams of carbon per kilo per visit. I'm not telling you a fact. I'm making a claim. When anybody's telling you their emissions, they're just making a claim. What is the evidence backing up your claim? That is what a manifest file is. It is the evidence to back up your claim. There's a lot of stuff we're doing in the space of the foundation about disclosure of emissions and using manifest files as your mechanism of disclosure. Are there cryptographic ways we could sign a manifest file so that we could prove that it's been done in a good way, things like that. And I talked about that. Yeah, so like let's say, and this is also our best guess. Maybe we're wrong. I don't know. It's science, right? Am I right? Am I wrong? Like challenge us. I want you to challenge us. We should all be challenging each other on kind of our ideas for how to compute emissions. This is a brand new field of computing. Like it's very early. No one really knows exactly what we're doing right now. So we're figuring it all out. Our YAML file is here. Go download it. Right. We have a whole tool chain that you can use. This is the YAML file that we've downloaded. You can see here. Oh, there's something interesting going on. I don't want to pull it. But this is that YAML file. Joseph built it. He used a couple of coefficients. I'm not going to. This is what we call a power curve. Let's say I disagree with this coefficient. I can then change it. Brilliant. I can then. Oh, shizzle. We have a tool chain, and I can then basically just rerun it There's a bunch of commands. I'm not going to go into them. You can go to the website, find all of our tooling, and I can then basically recompute it. I can then just check it back in as a pull request and go, Joseph, I think you're wrong. This is why I think you're wrong. And this is the impact of my computation. Full transparency. That's how we're going to get to the feature that we want. Where do you find those kind of like plugins, all those models? Like you can build them yourself, and actually a lot of them are just mostly coefficients. We ran a hackathon at the start of this year where we built the community built a lot of plugins. And so there's a lot of plugins you can find here. There's Prometheus, Quarters. There's AWS. There's Amazon. There's all sorts of different plugins to do all sorts of different things. One of my favorite is Death. You might guess. So Death is a plugin that you can import it, then you just add it to the end of your pipeline. Just one word, Death. You can add it to the end of your pipeline, and it will then tell you the number of people that will die because of your software, because of your choices, right? And it's backed up. We ask for every plugin to cite scientific papers if they're making any claims like this. This is a lot of citations in this repo. I can't find it right now, but they're there to kind of cite kind of where they got those values, those numbers from. And finally, like if you go to if.greensoftware.foundation, that's where you'll find kind of a lot of information about it. We're in the moment of like updating it. We're going to have a big update in a couple of months, so there's still a lot of work to do here. But that's where you can find all the documentation, pipelines, community, quick starts, things like that. I'm well over time. Oops. Okay, let me get back to the talk. Right, so a couple more things. So I mentioned the size and ISO standard, and this is just a conversation right now. This is not a consensus position, but we're now pushing for discussing those imp files, those YAML files, to actually be a specification, so that we can then anything can speak in. You can use every single software product in the world that computes an environmental impacts. There's hundreds of them right now. Right click, download imp file, and then we can start comparing and contrasting different tools and different things. How are you doing it? We can start communicating with each other. The way sustainability is like the web before HTML, and imp files are like HTML for the sustainability space. They just help us to talk to each other, just talk in a common language. And this is definitely beyond consensus. This is my dream. It's my personal dream. And we're working towards this seriously. There are significant strides in this in the Green Software Foundation. But the dream is this: every software product in the world will have to display a size score. It'll be mandated through policy. Every software product in the world will have to display a size score. But again, a size score is just a claim. You'll have to evidence that claim by showing a manifest file, by showing your workings out, showing your numbers. And I do speak to policymakers. They're like, this feels very like to what we want in this world. And if this hasn't kind of like landed for you right now, let me bring this back to power. You're like, why was I talking about power and I was talking about QR codes? So it is that now with Impact Framework, anyone can compute anyone else's emissions. You just take observations. Like you yourself from this audience could just we're quite an open foundation. There's a lot of data we generate ourselves. You could take the data that we provide. All our Git repos are open. You could look at it. You could try and observe what you can about our organization. Through a series of models, estimate what our emissions are. You can do that. We'd probably be able to do a better job, but you can still do something. You can measure our emissions. I don't know who you are. If you're in the audience, I'd be staring at a human being going, I can probably observe what I can from your organization and measure your emissions. Anyone can measure the environmental impacts of anything. Remember when BP created a carbon footprint calculator for you to measure your emissions? We've built a calculator so you can measure their emissions. as I said, it was a beautiful chess move, and I've meditated over it for years. Just really quickly, to make that come true, we need kind of like what something called watches. If you're kind of wondering, if you're wondering what to do with your time, where to put effort into this space, we're not we're not looking for people to build technology on top of Impact Framework. A lot of people out there, and we speak to them a lot, they look at Impact Framework and I'm like, oh, brilliant, I'm going to use Impact Framework, I'm going to build a layer on top, I'm going to build a dashboard, I'm going to build this, I'm going to build that. Good luck. We change all the time. We're alpha. We have no guarantees. The dev team will just go off and just make changes. We'll make your software obsolete in months. What we need in this world is not software that can measure emissions. We need people that know how to measure emissions. That YAML file I showed you, that required expertise. Right? The future will need thousands of people in this world who know how to measure environmental impacts of software. It'll be a role inside every software team. There'll be a watcher role. But we've got to start somewhere. Right now, there's just a handful of people. There's a couple of dozen people that are writing some manifest files, only a handful that really know the nuance of it, can really dive deep into it. We need to get more of them. So we're starting a program to get people to come in and to apply to become a watcher. So you can go in there, click, sign up. We're not going to start it till the start of next year. If you're thinking of something to do for like a hacking endeavor, measure. We're looking, just use Impact Framework to measure something. We need people who know how to measure. We need to learn how to measure better. That's what we're looking for, and that's what we need for the future. I would say, just like the first people tentatively exploring how to write software in an open way, those very first few people in this world, watchers are the first people exploring how to do impact measurement in an open way. I think a lot of us are going to be very proud to be watchers in the decades to come. So again, gruntstuff.org/watchers. I'll leave you with this final slide. Oh, shizzle, and I've only got maybe one. I've got too much time for questions. I do apologize. I truly believe this. If you're fully transparent, you can't be accused of greenwashing. You can only be accused of being wrong. My future that I want is every organization, every software product, everything has a fully transparent manifest file. And then if you don't agree with a claim made by an organization, you don't say they're greenwashing, you just say they're wrong, and you correct their manifest file and you send it back to them. That's how we'll all learn and grow together. I have another nerdy one. I'll just end it with this one. So it makes more sense in a live audience, actually, but I'll give it anyway. So what's this? This is a fathom. I don't know if you can see it. My arms are outstretched. It's a distance between one fingertip to the other fingertip. It's a fathom. But it can also be the start of a clap. I understand it doesn't quite work on StreamYard, but that kills when I give it to a live studio audience. That's the end of my talk. I'm going to try and get back to StreamYard. Stop sharing. And here we go. Oh, wow. YAML will change the world. That's it. Back. I don't know. So yeah, so if you want to just right now, we're just looking for people to get involved with Impact Framework. If you go to the Impact Framework if.greensoftware.foundation, there's a community section, and you can just join a mailing list. Just go, say hello, hi. You want to just try it out the tooling, give it a go, start learning about it, and if it feels like it's something that you want to get more involved with, apply to become a watcher. We're going to be creating a lot more 101 to kind of 201 to 301 training at the end of the year. There'll be courses you can take, but right now it's just there's just a few of us, kind of a small cadre of people. That's kind of how it starts. Another question? Oh, you're on mute, Mary.
Yes, I have a quick question I'd love to ask.
Sure.
I wonder if you could speak more. We have a lot of students in the chat, and I'm curious if you have any like particular recommendations for folks who are earlier in their career, like how do they either introduce these practices in their education or as an employee.
Yeah, I mean, I suppose we need to create that's why that's the world that we need to create is a world where every software product in the world is mandated. You have to calculate a psi score. So if that existed, then an entire ecosystem would exist where there'd be and I do work with a number of professors who kind of are actually introducing entire curriculums inside university to kind of learn this stuff. The challenge is there a job at the end of it? Is there kind of money at the end of it? The list of jobs in green software are very, 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 very small right now. So yes, true. We need to create kind of the economic incentives to make that like a $1 trillion industry. I want this to be $1 trillion industry. Seriously, the money's going to the renewable. The money's there. It's going to renewables energy. It's not going to us. We need to create that. But just start working with Impact Framework. If you do have any professors or if you're in universities, introduce them to the topic. One of the things I think is fascinating about Impact Framework and manifest files is that they can actually be used as a training tool. Like if you're teaching, like this is this architecture, I wrote this manifest file to estimate the emissions of this architecture. If we then move to this other architecture, I've now estimated the emissions that would go for. It can be a good teaching and training exercise to talk about the emissions of an architecture as you're kind of learning the technologies and the like. I do think it'd be a very good tool from there. But we've only just started having conversations with academia about it. I'm afraid I've got to jump.
No worries at all. Thank you so much for joining us. This was an awesome workshop. For folks who are watching, we'll have the recording of this up if you want to go back and catch any parts over again. But thank you so much, Asim, for coming and giving this workshop. Bye, everyone.
Thank you all. Thank you, Rory.